Now that we've proved that sine theta squared plus cosine theta squared equals 1, we can use the same method to prove that secant theta squared equals tangent theta squared plus 1. And so to prove this thing, we're going to have to use the same thing that we did in the last video. So to do that, we're going to say this side is A, this side is B, and this side is C. And we're going to take this angle to be theta. And so we know that secant theta is 1 over cosine theta. And we know that cosine theta is, so we know that cosine is adjacent over hypotenuse, which is B over C in our case. So this thing can be rewritten as 1 over, so cosine theta is, as we said, B over C. And since the whole thing, since the cosine is over 1, we just flip the value, the ratio. So that would be C over B. So secant theta equals C over B. So we can write this here. So secant theta equals C over B. And we can write tangent theta here. So we know that tangent is opposite over hypotenuse. That's A over B in our case. So now we can find the squares of both secant and tangent. So to do that, we're gonna take this equation first and square both sides. And from this we get secant theta squared equals C squared over B squared. And here, let me take this and move it here. And we can square both sides and say that tangent theta squared equals A squared over B squared. So we have to figure out what tangent theta squared plus 1 is. So we know that it's secant theta squared, but let's prove it. Let's prove that's the case. So that's tangent theta squared plus 1. And we know that tangent is A squared. Tangent theta squared is A squared over B squared. Comes from here. And plus 1. But we can rewrite 1 as B squared plus over B squared. So we can rewrite 1 as B squared over B squared. And from that we get what we get. So the denominators are the same. So we can leave the denominator as B squared. So since the denominators are the same, we're just going to add the numerators, which is A squared plus B squared. So we get that tangent theta squared plus 1 equals A squared plus B squared over B squared. And thanks to Pythagorean theorem, we know that for any right triangle, A squared plus B squared, so let me do this in white. So we know that A squared plus B squared equals C squared, where this is A, this is B, this is C, and this is 90 degrees. So from that we get, so this and this. So tangent theta squared plus 1 equals, so the denominator stays the same. And we know that A squared plus B squared equals C squared. So we can rewrite this as C squared. And since C squared over B squared is secant theta squared, we can say that tangent theta squared plus 1 equals secant theta squared.